Hi friends, welcome back. We're talking today about geometric probability as area. So remember, probability is just your favorable over your total possible. We want to find the probability that a randomly chosen point is in the shaded area on this guy right here. So the best way to do these is to do this. You're going to come up with white, shaded, and total. White, shaded, and total. Now, let's see, we've got two figures here. The total is usually your easiest one to figure out because that is our big one that we got here. That's our circle, right? And right here in the center. So we have this circle right here. And in order to find the area of a circle, remember, it's the radius squared times pi. So we need our radius. And if you look here, it looks like we've got the radius right here. It's 2. So the radius, or I'm sorry, I wrote circumference, but I meant area. So our area is going to be 4 pi equals 4 pi units. So we'll leave it as 4 pi for right now for our total. 4 pi units squared. Okay, so what about the area of the white part here? So the white part is a square, right? And so we've got this square like this in the area. We just need to find the length of one side in order to figure out the area of this. Well, I see that there's a triangle in there, and if I can figure out, so we've got this triangle right here, like this guy, like that. So we have a right triangle in there. It looks like this, right? And we know our hypotenuse is 2, and then we know this guy is root 2. Now this is what we're looking for, so I'm going to call that x. Remember, when you have a right triangle, you can always use your Pythagorean theorem. So we can say, okay, square root of 2 squared plus x squared equals 2 squared, because remember, our hypotenuse is always across from that side. So that's going to give us 2, because this cancels out that, plus x squared equals 4. So x squared equals 2. Square root both sides, you get x equals the square root of 2. That makes sense on these, but I just wanted you to see that. So we know that this guy is the square root of 2 here, but we have 2 of them, right? So we add those together, we have 2 root 2. So on our square, one whole side is 2 root 2. And this side is 2 root 2. So in order to find the area of our square, we have to take 2 root 2 times 2 root 2. And if it helps to visualize it, this is what we're doing. 2 times root 2 times 2 times root 2. Well, 2 times 2 is 4. And root 2 times root 2 is root 4, which is really just 2. So it's times 2. So our area is 8. Okay, so now we know that the area of the white bit is going to be 8 units. So if we take the total, and at this point, let's go ahead and do approximate. So when we do this, make sure to use your pi button so that we are using 3.1415, right? So this is approximately 12.57 units. So to find our shaded, we would just have to minus 8 from that and give us 4.57 units. Squared, units squared, units, units squared. Okay, so so with all of that information, once you figured out like the non-shaded, the shaded, and your total, remember our probability is, so the probability of the shaded, we want to know it's in the shaded region. So that's let me slide that back down. That's our favorable. So our total possible is going to be 12.57, and our favorable is the shaded bit, which is 4.57. So if we take those two, let's divide that. We get 4.57 divided by 12.57. We end up with 0.3636 roughly. I'm just rounding there. So turn that into a percent. Remember, percent has a percent sign has 2 dots, so move it 2 spots over if that helps. 1, 2. So we end up with 36.36%. So what are the chances that it lands in that shaded area? Roughly 36% And that seems about right. Like it doesn't look like it's more than half or something like that. So I think that that helps. Let's try another one. Okay, so let's take a look this time with triangles. So we've got this triangle here. What is the probability that a point chosen at random lands in the shaded bit? Well, again, we need to have the shaded, unshaded, or white part, and we have to have the total. Okay, so remember, to find the area of a triangle, you measure the base times the height and you cut it in half. So straight away, figuring out the total is this big one, right? All we have to do is 14 times 12, and then whatever that is, cut that in half. And if we do that, we end up with 84. So, and so that would be 14 times 12 divided by 2 equals 84. Just putting a little bit of notes in there so that you can see that that's how I got that information. Okay, what about the shaded part? Well, this is a good one. It looks like we know that these guys are congruent to each other. And if this whole thing is 14, that means that they both have to equal 7. So this is going to be 7 and this is going to be 7. So for this shaded part, we can figure out that part by saying 7 times 6 divided by 2, and that will give us 7 times 3, so that would be 21, right? So we've got our shaded bit is 21. All right, now we have to find the unshaded. Well, all we have to do is take 84 minus 21, and just making sure I don't mess this up, hold on. 84 minus 21, and we end up with 63, okay. 63, and that is our unshaded bit. So, okay, now that we have this, we want to figure out what the probability is that the shaded part being our favorable. So our total possible is 84, and our shaded is our favorable, and that's 21. So we have 21 out of 84. 21 out of 84. And if we reduce that, we end up with 0.25 or 25 hundredths, which is about 25%. So the chance of picking a point out of the blue spot would be about 25%. So hopefully that makes sense. If you have any questions, leave them below. Otherwise, we'll see you next time.